Okay, let's take a look at this first problem. And get my pen to work. There it goes. Okay, problem number 1. We got 5 times x plus 5 plus 7 equals negative 8. Okay, we're going to go through our 4 steps. Our first step for solving a linear equation is to get rid of parentheses. So we're going to take the, and what tells me the distributive property is I got a number right next to parentheses like that, and we got 2 terms inside here. So we're going to use the distributive property. We're going to take 5 times x and 5 times 5. 5 times x is 5x. 5 times 5 is 25. Plus 7 equals negative 8. Now our note up at top says in a step, combine together like terms, combine together numbers. Well, we can combine these together. So we got 25 plus 7 gives us 32. Step 2 in solving linear equations is get rid of fractions. Don't have any. Step 3 is to get everything with an x on one side, numbers on the other. So I'll take 32 and move it over to the right side. You take anything across or equals, your sign changes, so the positive 32 becomes a negative 32. Again, our note up at top says in a step combine together numbers. Negative 8, negative 32 is negative 40. Step 4. Divide both sides by a number in front of our x. Number in front of our x is a 5, so we're going to divide both sides by 5. And negative 40 divided by 5 gives us negative 8. So that'd be our answer. So let me put that in here. And then go to the next question. Okay, let's take a look at this one. So problem number 2, we have 2 times 3x plus 2 equals 5 times x minus 3. And we'll go through our 4 steps. First step is get rid of parentheses. So I'm going to take this 2, we'll do that via the distributive property. Take the 2 and multiply it times the 3x and times the 2. And then we'll take this 5 and multiply it times the x and times the negative 3. 2 times 3x gives us 6x. 2 times 2 is 4. 5 times x is 5x. 5 times negative 3 is negative 15. Step 2, get rid of fractions. Don't have any. Step 3 is get everything with an x on one side and numbers on the other. So I'm going to take this 5x and move it to the left side. And I'll take this 4 and move it to the right side. Now when you take anything across your equals, your sign changes. So the positive 5x becomes a negative 5x. The positive 4 becomes a negative 4. Now at any step, combine together like terms. 6x minus 5x gives us 1x, or just x. And at any step, combine together numbers. Negative 15, negative 4 is negative 20, negative 19. Whew. I watched myself this morning. Negative 19. Okay, let's take a look at our next problem. Start a new page. Okay. We got negative 6/5 x, or negative 6/5 times x plus 10, plus 1/5 x is equal to negative 8. And we'll go through our 4 steps again. Our first step is to get rid of parentheses. So I'm going to take this negative 6/5, and using the distributive property, I'll multiply it times the x and times the 10. So we got negative 6/5 x minus 6/5 times 10 plus 1/5 x is equal to negative 8. Okay, well the 5 and 10 are both divisible by 5. 5 divided by 5 is 1, 10 divided by 5 is 2. So we're going to have negative 6/5 x minus 6 times 2 is 12 plus 1/5 x equals negative 8. Now, if you stink at fractions, you could plug this into your calculator. Okay, negative 6/5, so negative 6 divided by 5 times 10. Enter. And you see we get our negative 12, which we have right here. So just because I'm doing it by hand here doesn't mean you necessarily have to. Step 2, get rid of fractions. And how we get rid of fractions, we multiply everything by the LCM of all our denominators. We got two denominators, and they're both 5, so our LCM would be 5. So I'll take 5 times negative 6/5 x, take 5 times negative 12, 5 times 1/5 x, and 5 times negative 8. When I say multiply times everything, I'm talking about what's separated by pluses, minuses, and equals. So we multiply by this first fraction. Here's a minus, so we multiply it by that number. Here's a plus, we multiply by that term. And here's a number, so we multiply it times that number on the right side. And then we start canceling. Now 5 and 5 are both divisible by 5. 5 divided by 5 is 1. 5 divided by 5 is 1. And here, again, 5 divided by 5 is 1. 5 divided by 5 is 1. If all of your denominators have disappeared, that means you picked the right LCM, or at least picked a common multiple. Now 1 times negative 6 is negative 6x. 5 times negative 12 is negative 60. 1 times 1 is 1x, or you can just write x. 5 times negative 8 is negative 40. Now I didn't combine together the like terms up here. I could have combined this and this at this step, but typically it's easier to get rid of the fractions first and then combine together like terms, which is what we'll do now. So I got negative 6x plus 1x. That's going to give us negative 5x minus 60 equals negative 40. Step 3. Get everything with an x on one side, numbers on the other side. So I'm going to take this negative 60 and move it to the right side. So we're going to have negative 5x equals negative 40, and the negative 60 becomes a positive 60. So we got negative 5x, excuse me for clearing my throat. Negative 40 plus 60 is 20. Always combine numbers in a step. Now step 4. Divide both sides by the number in front of your x. The number in front of our x is a negative 5. So we're going to divide both sides by a negative 5. And 20 divided by negative 5 is negative 4, which would be your answer. There's a show as good as it gets, or something like that, with Jack Nicholson. And he's always clearing his throat right before he answers the phone. While he's on the phone. Clever movie. Okay. Let's look at our next problem. And I'll start a new page. And hopefully I don't have any basic math errors as I'm going through here. Okay, problem number 4. We got 1/3 x plus 2/5 equals 11/15. Okay, first step is to get rid of parentheses. Don't have any. Second step is to get rid of fractions. We're going to multiply by the LCM of all our denominators. So we need to find the LCM of our denominators. So I'm going to show those steps over here. We got 3, 5, and 15. The first step in finding the LCM of numbers is to write the prime factorization of each number down. Now 3 is prime, so we just write down 3. 5 is prime, so we just write down 5. And 15. If we did our tree and start with our first prime, which is 2, we ask ourselves if it's divisible by 2, and it isn't. So we go to our next prime, which is 3. And it is divisible by 3. 3 times 5 gives you 15. Now 3 is prime, so we circle it, and 5 is prime, so we circle it. So 15 would be 3 times 5. Now our LCM. We start with our first prime, the 3. We're looking for the greatest number of 3's on a single line. There's 1 here, none here, 1 here. So greatest number of 3's on a single line is 1. We're not counting how many there are. We're looking for the greatest number of them on a single line. And I'm talking about to the right of the equals. Let's go to our next prime, which is 5. And I'm looking for the greatest number of 5s on a single line. There's none here, 1 here, 1 here. So our greatest number of 5s on a single line is 1. So our LCM would be 15. Now some of you could just see that. Okay, so we're going to multiply everything by 15. We'll multiply it times our first fraction. We'll multiply it times our second fraction. And we'll multiply it times our fraction on the right side. Okay. 3 and 15 are both divisible by 3. 3 divided by 3 is 1. 15 divided by 3 is 5. 5 and 15, both divisible by 5. 5 divided by 5 is 1. 15 divided by 5 is 3. 15 and 15, both divisible by 15. 15 divided by 15 is 1. 15 divided by 15 is 1. Again, if your denominators have all disappeared and there's 1s there, that means you picked the right LCM, or at least picked a common multiple. 5 times 1 is 5, so we got 5x, plus 3 times 2 is 6, equals 1 times 11, which is 11. Step 3. Get everything with an x on one side, numbers on the other side. So I'll take that 6 and move it over to the right side. Now when you move anything across the equals, the sign changes, so the positive 6 becomes a negative 6. Now our note up at the top says any step combined together like terms, combine together numbers. 11 minus 6 is 5. And then step 4. Divide both sides by a number in front of your x. Number in front of x is a 5, so we're going to divide both sides by 5. And 5 divided by 5 is 1, which would be our answer. Okay. Next problem. Let me start a new page. And what problem is this? Problem 5? Okay. So we got 5a over 9. Fortunately, my a's kind of look like 9s. Let's try it again. A. I could equally just put an x there if I wanted to. Minus 2a over 5 equals 7/3. Okay, first step, get rid of parentheses. Don't have any. Second step, get rid of fractions. And how we get rid of fractions, we multiply by the LCM of all their denominators. And if you can see it, fantastic, but I'm going to come over here and find it. Our first step in finding the LCM is write prime factorization of each number down. Now 5 is already prime and 3 is already prime, so I just leave those as is. But the 9, if I did my tree breakdown, I start with my first prime, which is 2. It's not divisible by 2, so I go on to my next prime, which is 3. It is divisible by 3. 3 times 3. Now 3 is prime and 3 is prime, so I circle those. So our prime factorization would be 3 times 3. So I don't know what in the world that was. Our LCM, we start with our first prime, which is 3. Now I'm looking for the greatest number of 3's on a single line, and I'm looking to the right of the equals. There's 2 of them here, there's none of them here, there's 1 of them here. So our greatest number of 3's on a single line is 2 of them. Then I go to my next prime, which is 5, and I'm looking for the greatest number of 5's on a single line. None here, 1 here, none here. So greatest number of 5's on a single line is 1. 3 times 3 is 9, times 5 is 45. So I'm going to multiply everything by 45. I'll multiply it times this first fraction, times the 5a over 9. And I'll multiply it times this second fraction. Now notice this time I put the negative out in front. It doesn't matter where you put it. And I'll take 45 times the fraction on the right side. Now 45 and 9 are both divisible by 9. 9 divided by 9 is 1. 45 divided by 9 is 5. 5 and 45 both divisible by 5. 5 divided by 5 is 1. 45 divided by 5 is 9. 3 and 45 both divisible by 3. 3 divided by 3 is 1. 45 divided by 3 is 15. So we're left with 5 times 5, which is 25a, minus 9 times 2, which is 18a, equals 15 times 7, which is 105, I believe. 5, 3, yeah, 105. Now notice these were like terms up here at the very beginning. I could have combined those together, but not very easy. Now, look how easy these are. We'll combine those like terms. At any step, combine together like terms. So that gives us 25a minus 18a gives us 7a equals 105. Okay, step 3. Get everything with an a on one side, numbers on the other side. That's done. Step 4. Divide both sides by a number in front of your a. So we're going to divide both sides by 7. And we get a is equal to 15. Assuming I did my basic math right. Not very good at basic math. Okay, 15. And let's go to problem number 6. And I'll start a new page. And problem number 6. We got 5x minus 13 over 5. Well, sometimes it doesn't allow me to flip back and forth like it should. Plus x over 20 equals x over 4 minus 1. Okay, first step, get rid of parentheses. Don't have any. Second step, get rid of fractions. Multiply everything by the LCM of all your denominators. Well, let's come over here, find the LCM of 5, 20, and 4. Now our first step in finding the LCM is we write the prime factorization of each number down. Now 5 is prime, so we just write 5. 20. If I did my tree breakdown, start with my first prime, which is 2. It is divisible by 2. 2 times 10. 2's prime, so I circle it. Now I go to the 10. I'm still on my first prime, which is 2, and it is divisible by 2. 2 times 5. 2's prime, so we circle it, and actually 5's prime, so we circle it too. So 20 will be 2 times 2 times 5. Now 4. I start with my first prime, which is 2, and it is divisible by 2. 2 times 2. 2's prime, so we circle it, and 2's prime, so we circle it. So 4 is 2 times 2. So our LCM. We start with our first prime, which is 2, and we're looking on the right side of the equals. Now I'm looking for the greatest number of 2's on any single line. There's none here, there's 2 here, there's 2 here. So the greatest number of 2's on any single line is 2. Then I go to my next prime, which is 5, and I'm looking for the greatest number of 5's on any single line. And I'm talking about to the right of the equals. So there's 1 here, there's 1 here, there's none here. So the greatest number of 5's on any single line is 1. 2 times 2 is 4, times 5 is 20. So we're going to multiply everything by 20. We'll multiply it times this first fraction. Now it's a hideous fraction, but it's still just a single fraction, so we want to keep it together. We'll multiply it times this second fraction. We'll multiply it times this fraction on the right side, and we'll multiply it times the negative 1. When I say multiply it by everything, I'm talking about what's separated by pluses, minuses, and equals. Keeping in mind, you do not want to split up a single fraction. Okay. Well, 20 and 5 both divisible by 5. 5 divided by 5 is 1. 20 divided by 5 is 4. 20 and 20 both divisible by 20. 20 divided by 20 is 1. 20 divided by 20 is 1. 4 and 20 both divisible by 4. 4 divided by 4 is 1. 20 divided by 4 is 5. Now notice that all of our denominators have disappeared. We're left with 1's down there. That means it worked. So I'm going to write down what I have left before I multiply it through. So 4 times 5x minus 13 plus 1 times x equals 5 times x plus 20 times negative 1. Now this first set of parentheses we'll use distributive property on because we've got two terms inside. So we're going to take 4 times 5x gives us 20x. 4 times negative 13 gives us negative 52. Plus 1 times x is just x equals 5x. 20 times negative 1 is negative 20. Now note up at top says that any step combine together like terms. So we can add together the x's on the left side. 20x plus x is 21x. Minus 52 equals 5x minus 20. Okay, step 3. Get everything with an x on one side, numbers on the other side. So I'm going to take this 5x and move it to the left side, and I'll take this negative 52 and move it to the right side. Now anytime you take anything across your equals, your sign changes, so the positive 5x becomes a negative 5x. The negative 52 becomes a positive 52. Combine together like terms in a step. 21x minus 5x gives us 16x. Combine together numbers in a step. Negative 20 plus 52 gives us 32. Step 4. Divide both sides by number in front of your x. Number in front of our x is a 16, so we'll divide both sides by 16. And we get x is equal to 2. These are all coming out pretty nice answers. Not nice problems necessarily, but the answers come up fairly nice. Okay, now we got a formula. So let me start a new page again. This is what, problem 7. Got A is equal to P plus PRT, and we're solving that for R. Well, now we're going to our 5 steps for solving a formula for a variable. Now, first step is get rid of parentheses. Don't have any. Second step is get rid of fractions. Don't have any. Third step, get everything with the variable we're solving for on one side, everything else on the other side. We're solving for R, so I'm going to take this P and move it over to the left side. Now remember, when you move anything across your equals, your sign changes, so the positive becomes positive P becomes a negative P. And left with this. So now we have everything with an R on the right side and everything else on the other side. Step 4. If possible, factor out the variable you're solving for. You'd have to have 2 R's over here, so we can't do step 4. Step 5. Divide both sides by what's in front of / behind the variable you're solving for. There's a P in front of it and there's a T after it. So we're going to divide both sides by PT. Now when you do that, those P's are going to cancel and those T's will cancel. And over on this side, we're going to have R is equal to A minus P over PT. Now let's see what kind of form they want us to put the answer in. Oh, they already have R equals. Okay, good. A minus P, I'm going to do a fraction, so I click this. And then I'll do A minus P and tab PT. Was that A minus P? Yeah. And then PT. PT. And let's say next question. Okay. Now we got a linear inequality. And I probably got room here for it. Got 5x minus 6 is greater than 4. And probably wants to solve it, I'm assuming. Express solutions. Okay, solve it, yeah. First step. And these are the 4 steps for solving a linear inequality. So our first step is get rid of parentheses. Don't have any. Second step is get rid of fractions. Don't have any. Third step is to get everything with an x on the left side, numbers on the right side. So I'm going to take the negative 6 and I'll move it to the right side. Now when you take anything across your inequality symbol, the sign changes. So the negative 6 becomes a positive 6. Now our note up at top said any step combine together like terms, combine together numbers. 4 plus 6 is 10. Our fourth step in solving a linear inequality is to divide both sides by the number in front of your x. Well, the number in front of our x is a 5. So we're going to divide both sides by 5. So we get x is greater than 2. Now this is our answer. Set builder notation means we put an x, curly brackets, x with a vertical bar, and then whatever we came up with. And so here, express the solution set in set builder notation. So I'm going to click there, and then in the blank I want to put x is greater than 2. So x is greater than 2. Okay, this says express the solution set in interval notation. Whenever you got a greater than, it's going to positive infinity. So we got 2 comma positive infinity. Infinities always have parentheses on them. Now, to decide what goes on a 2, if you have a line underneath here, a greater than or equal to, so a line underneath, you put a bracket. If you don't have a line, you put a parentheses automatically. So that'll be our interval notation. So I'll put, how do I do the parentheses? I guess just put them. 2 comma infinity. Well, here's an infinity symbol. That makes it easy. And then a closing parentheses. Now the graph. Graph is very straightforward. If you have interval notation, parentheses on 2, parentheses on 2. And you shade whichever way it's opening. It's shading to the right, so I shade to the right. So, that one looks close. That's in blank. That's a bracket, parentheses. This is everything. So it looks like it's between B and D. They're both at 2, so that's good. But remember, I shaded to the right, so it'd be B. So I click next question. Number 9. Let me start a new page. And let's take a look at number 9. We got 2n minus 6 times n minus 4 is greater than 4n minus 24. And we're going through our 4 steps for solving a linear inequality. First step, get rid of parentheses. So I'm going to take this negative 6 and I'll multiply it times the n and multiply it times the negative 4. Well, negative 6 times n is negative 6n. Negative 6 times negative 4 is positive 24. Everything else carries down. At any step, combine together like terms. 2n minus 6n gives us negative 4n plus 24 is greater than 4n minus 24. Okay, second step, get rid of fractions. Don't have any. Third step, get everything with n. Now our steps say x, but you can change it to whatever variable you want. So get everything with an n on the left side, numbers on the right side. So I'm going to take this positive 4n over the left side, it becomes a negative 4n. And I'll take this positive 24 over and it becomes a negative 24. Now at any step, combine together like terms. Negative 4n and negative 4n gives us negative 8n. And combine together numbers. Negative 24 is negative 48. Step 4. Divide both sides by a number in front of your n, which is a negative 8. Now remember, when we divide by a negative number, we flip our inequality symbol. So the greater than becomes a less than. So we got n is less than negative 48 divided by negative 8 is 6. Now since it looks like they're going to want it all, let's do our set builder. Again, we put curly brackets in with a vertical bar and then whatever our answer was. Interval notation. It's a less than, so it's going to negative infinity. And infinities always have parentheses on them. And there's no line underneath the inequality symbol. If you have a line underneath, that's when you put a bracket. So we're automatically going to put a parentheses. Now graph-wise, parentheses on a 6, parentheses on a 6, and we shade whichever way it's opening, and it's opening to the left. So let's go input our answers. Okay. Here we got n is less than 6. Here's our interval notation, I'm assuming. I should probably read the instructions. So I'll have negative infinity, comma, 6, and then parentheses. And 1, 2, 3, 4, 5, 6. Well, that's a bracket. 1, 2, 3, 4, 5, 6 parentheses. I think I shaded to the left, didn't I? Yes, I did. Okay, so now I'll say next question. And last question. So let me start a new page. And then we'll see how I did, see if I missed any problems. You always hate to miss problems when you're creating a key or a key for the the review. Doesn't instill confidence very much, but we all make mistakes. Okay, now I'm going to go through my 4 steps for solving a linear inequality. First step is get rid of parentheses, don't have any. Second step, get rid of fractions. Multiply by the LCM of all their denominators. Well, if I looked at finding the LCM of 6 and 5, and some of you can see it's 30, and that's fine. I can too. But I'm going to show this in case you can't see it. Well, 5's prime, so we just write 5. Now 6, if I did my tree breakdown, I start with my first prime, which is 2. 2 times 3. 2's prime, so we circle it, and 3's prime, so we circle it. So we got 2 times 3. So for our LCM, we start with our first prime, which is 2. We're looking for the greatest number of 2's on any single line. There's 1 here, none here, so the greatest number on single line is 1. Then we'll go to our 3. We're looking for the greatest number of 3's on a single line. 1 here, none here, so it'd be 1. And then we go to our 5. We're looking for the greatest number of 5's on a single line. None here, 1 here, so it'd be 1. And 2 times 3 is 6, times 5 is 30. So we're going to multiply it times our first fraction. Nasty looking fraction, but still a single fraction. We'll multiply it times the 7. We'll multiply it times the fraction on the right side. And we'll multiply it times the 3. Everything's separated by pluses, minuses, and inequality symbols, but keep it in mind we do not want to split up a single fraction. Okay. 30 and 6 both divisible by 6. 6 divided by 6 is 1. 30 divided by 6 is 5. 5 and 30 both divisible by 5. 5 divided by 5 is 1. 30 divided by 5 is 6. Now I'm going to write down what I have left before I multiply it through. So we got 5 times x plus 9 plus 30 times 7 is greater than 6 times x plus 2 plus 30 times 3. Some of these we use the distributive property on because there's 2 terms inside. So in this one we'll take the 5, multiply times the x, and times the 9. In this one we'll take the 6 times the x and times the 2. 5 times x is 5x, 5 times 9 is 45. 30 times 7 is 210. 6 times x is 6x, 6 times 2 is 12. 30 times 3 is 90. Now at any step combine together the numbers. We got 45 plus 210, that gives us 255. At any step combine together numbers, 12 plus 90 is 102. Okay, third step. Get everything with an x on the left side, numbers on the right side. So I'll take this 6x, move it to the left side, take this 255, move it to the right side. You take anything across your inequality symbol, the sign changes, so the 6x becomes a negative 6x. The 255 becomes a negative 255. Now at any step, combine together like terms. 5x minus 6x is negative 1x, greater than, this is like a basic math error waiting to happen. 315, negative 153. Yeah. Okay, last step. Divide both sides by number in front of your x. Well, number in front of our x is a negative 1, so I divide both sides by negative 1. And we flip our inequality symbol, because anytime you divide by a negative number, you have to flip it. And we get x is less than 153. Now set builder notation. You put curly brackets, x with a vertical bar, and x is less than 153. Now interval notation. It's less than, so it's going to negative infinity. Infinities always have parentheses on them. Less than doesn't have a line underneath, so we're going to have parentheses again. Graph, parentheses 153, parentheses 153, and you shade whichever way it's opening, which is to the left. So let's go enter that in. Let's see, the solution is x is less than 153. We said this was on negative infinity, comma 153. And we're shading to the left, it's 153 and it's parentheses, which would be C. Okay, moment of truth. Let's see how many I screwed up. 100%. That's always a good sign. Anyway, that's the test review for the second test.